All right, so let's do a problem about imaginary numbers. First of all, this is Nora from Sis Enrichment Center. We're in Glendale. So I'm Pacific. Phone number is 818-731-8207. If you need help, call Nancy. But right now, let's do some imaginary number. The question is, this is from Integrated Math 2 book, right? And it says, rewrite each expression below in terms of probably I. It doesn't say in what terms, but that's what they mean from the problem that I see. So here it is. There's a problem. They have this page 308, Integrated Math 2, and then problem number 5, 131, chapter 5, problem 131, and it's negative square root of negative 49. And another one is square root of negative 2, and then we'll do some more. So what is this? This is, first of all, what is I? In this case, we see this is square root, second root, right? We don't put the second there, but that's what it means, second root. Means you say, what two numbers, what number multiplied by itself? Basically twice, not the two different numbers, same number. Multiplied by itself, you get negative 49. If this was, just a little bit of review, if this was like 49, square root of 49, say, and if they ask, what is that 49? It means what number multiplied by itself is 49. And then, so it's one number, and it's clearly 7, right? That's equal to 7. 7 times 7 is 49. But when they say what number multiplied by itself is negative 49, it's not possible because it's negative. It's not, you cannot say it's negative 7 times negative 7 because that's going to be positive 49. And you cannot say positive 7 times positive 7 because that's 49. And you cannot say negative 7 times 7, which is negative 40, but you cannot say because I said what numbers multiply by itself, same number, they're not same. None of this works. So when you have even roots, in this case, it's second root. So here's the conclusion. When you have even roots, like this case, second root, fourth root, sixth root, and all the evens, it means numbers that you multiply 2 times to each other, 4 times to each other, 6 times to each other, 8 times, all these. And if there's a negative inside the radical, there's no real number. There is no real answer. There is no real answer. There is an answer for that, but it's not real. It's called imaginary numbers. Okay? So how do we deal with that? That's the topic of this chapter and section. So we say, let's do this. There's an imaginary number, which is I. We define it. And this I, imaginary I, is equal to rad negative 1. So I is rad negative 1. By definition, I is equal to rad negative 1. And then, so we break this negative rad 49 and say, that's actually, isn't it, rad negative 1 times rad 49? So we isolated it. We came up with this rad 49 now, so we can tell. We can say what number multiplied by itself is 7. We isolate, we take out this piece that we don't like. You guys don't like, engineers like it. Every day, 20 hours a day, they deal with imaginary numbers. So here it is. This is the imaginary number we isolated. Negative rad negative 1 times rad 49 is rad negative 49. So when we do that, that's easy. We're just going to say, what is 49? Rad 49, that's 7. And what is rad negative 1? By definition, we said it's I. So it's I. I times 7, we don't put I7. We say 7I. That's it. So rad 40 negative 49 is 7I. How do we deal with the other one? And just in a little space, because that doesn't require much space now. What is rad negative 2? In this case, that's again same thing, isolate. Even though this is not a perfect square number, 45, we got lucky with the first problem. 45 is a perfect square number because we know what number multiplied by itself. There's a whole number, it's 7. Multiplied by itself is going to be 49, but rad 2 is not. Can you find a number multiplied by itself? It's 1.41, I don't know, continuous, it's irrational. But, so we don't have a whole number for 2. We're just going to leave it like that. But before that, again, we need to isolate what we just did here. Then I say, isn't a rad negative 2 same as, get rid of rad negative 1. Is it times rad negative 1 times rad 2? See, Radicals, you draw one radical and multiply the number inside radical together. -1 times 2 is -2. That's what you're going to get. That's multiplication. So now we isolated it. What is this? That's I. And just leave that like that. You cannot break it, right? You're not going to get a whole number. Just leave it like that. It's I times rad2, I rad2. If you want to put the rad2 I, you can do that too. But now I rad2 is better. So or rad2 I. See how the book prefers, your teacher prefers. So they're both same. That's what second one. And then now we have 4i squared. So this one, now a little bit different stuff. 4i squared. That's the 131c. So 4i, oh, I said squared, but I put cubed to the second power. First of all, something that you need to know is this. Before that, I'm going to simplify this imaginaries here for you. So simple, and just 2-3 minutes. How much time we have? Enough time we have. So we talked about I and said I is equal to rad -1. All right. So we're going to figure out what is I squared. I squared is what, isn't it? Rad -1 times rad -1. Rad -1 times rad -1 is just rad 1, and rad 1 is 1. That's nice now. See? I squared becomes 1. We need the conclusions. These are things that you need to know. Now, you don't need to really memorize it because see how easy it was. I calculated it. Third one, how about I to the third? I cubed. So isn't it I cubed is I squared times I. So I squared is 1. 1 times, that's time. 1 times rad -1 is what? So, oops, something here. We missed it, huh? Rad -1 times rad -1. No one told me. You guys didn't tell me when you were watching it. You don't have a microphone? Rad -1 times rad -1 is -1. Rad -1 times rad -1. So it's like rad 2 times rad 2 is just 2. That's -1. So be careful with this one. How come I tripped it? So same thing here. I figured that something is all right. I squared is what? -1. -1 times rad -1 is what? Negative rad -1. Probably some people got it. Said, oh, I got it, but they were yelling. I didn't hear it. Sorry. Just making it funny. So there it is. Right? We don't really write it like that. We write it like this. I to the third is same as -I, because this was I, right? So -I. It's opposite of I. That's I to the third. What is I to the fourth? That's a good one. I fourth, isn't it? I squared times I squared. And I squared is -1, right? And I squared is again -1. You multiply together, you get 1. That's a good one. I to the fourth is 1. See? This is equal to this. So from here, there's a pattern. I'll teach you this pattern, then you can do lots of these problems. Ooh, get rid of it. The eraser is bad. So, maybe this is not clean. Now, pattern is what? Look at this. I fourth is that, right? What is next one? I fifth. I to the fifth, I'll write it here. Isn't it I fourth is I fifth is same as I fourth times I first. So it's going to be 1 times I to -1. No, times I, which is rad -1. This times this is I to the fifth. So 1 doesn't do anything. Basically, it becomes I fifth equal to I. Is that clear? So I sixth is same as I fourth. Why I keep multiplying I fourth to all of these, you will see, because I fourth is 1, so it doesn't make any difference. 1 times I squared. Therefore, because that's 1 times this -1, we get same thing, you get -1. So I to the 6th is same as I squared. And I to the 7th, same thing. So it's going to be I to the 7th is what? I to the 4th times I to the 3rd. So 1 times I to I to the third, which is this, right? That's I to the third. So basically, I to the seventh equal to I to the third, because you're multiplying 1. So it's same as I to the third. And I to the third was what? Negative I. So that's equal to negative I. I to the 8 is same as I to the 4th times I to the 4th. Just 1 times 1, 1. You see the pattern? If I go I to the 9, it's going to be the same thing. It's going to be the same as I. And I to the 10 is going to be same as I squared. This one. And I to the 11 is same as I to the third. And I to the 12 is same as I to the 4th. And if I tell you how about I to the power of 27, this is what you do. You divide 27, divide by 4, because it goes by 4. 1, 2, 3, 4. Divide by 4 and find the remainder. Remainder is 6 times 4, 24. Remainder is 3. That's same as I to the third power. Follow this pattern and you see. This is 4, 5, 6, 7, 8, 12, 16. This is 16, I to the 16. That's same as I to the power of 20. Then I to the power of 24. Then I, see, 24. So it's going to be, this is 25th, 26, 27. Same as I to the third, you see? So if they ask, what is I to the power of 51? So 51 divided by 4. It's going to be 48 is what? 12, right? So the remainder is what? 4 times 12 is 48. Remainder is 3. So you don't need to find the remainder. Remainder is 3. So that's again same as I to the third. Cool? Now let's do this problem. This was much simpler. So I explained kind of more so that you understand really how to deal with eyes. Not blue eyes, just eyes. So 4i squared. Right? In this case, this 2 is power for this whole thing inside parentheses. That's same as 4 squared times I squared. So 4 squared is what? 16. And I squared, what is I squared? Isn't it rad negative 1 times rad negative 1? That tricked us, which is equal to negative 1, right? That's going to be negative 1. That's going to be negative 16. That's it. So next one, what is next one?
It's 3i plus 2i minus 5.
3i plus 2i minus 5, right? Mm-hmm. So 3i plus 2i is just simply adding. So 3i, it's like 3x plus 2x, 5x, right? 3i plus 2i, which is 5i minus 5. That's done. We cannot simplify. You don't need to write it 5 rad negative 1 minus 5. I is rad negative 1, but we don't want to. We don't want to see rad negative 1. That's what we don't like. That's why we came up with this I, so that this rad negative 1 is not in front of our face. So we don't want to see this. So, and that's why we write it AI plus B. A times I plus B. In this case, AI plus B. In this case, negative 16 is again in AI plus B, because it's 0i minus 16. 0 is gone. 0i is gone, so you get negative 16. Right? So do you have more questions? All right, that concludes Imaginaries here again. This is from Sis Enrichment Center in Glendale, California.